In the world of performance road bikes, carbon fibre has become the go-to material. It's light, it's stiff, it can be formed into pretty much any shape. But behind any material, there is a whole world of science, precision manufacturing and knowledge. And in this video, I've decided to catch up with an expert to find out all. Dr. Peter Giddings is Chief Engineer at NCC, the UK's national R&D centre for composite materials, and is also a keen lifelong cyclist. So when it comes to learning more about the material used in our carbon fibre bikes, he's the perfect person to talk to. Peter, thanks so much for joining us today. I'm really interested to pick your brains on all things carbon fibre. Should we just kind of start off from the basics and get into it? What in your book is the different what does different modulus mean? That's a really key word.
Yeah, so it's probably worth saying carbon fibre is the string. Carbon fibre composites is a material that we ride bikes from. That's carbon fibres bound together by resin, which is a jazzy word for glue. And that the modulus of the fibres is how stiff they are. The modulus is an engineering word for stiffness. To the engineers who know the exact definition, I'm sorry, but the useful definition is its stiffness. How far something will stretch if you pull on it a certain amount. Modulus doesn't mean strength. It's probably the only thing that really annoys me when people talk about composites. They say modulus and then strength, like they're the same thing. They're different.
So when you hear of a bike frame that's described as 3K modulus, what's the difference between a 3K and a 6K?
So K means the number of individual strands in one tow or yarn of carbon. So carbon comes literally in string, like a ball of black string, and if it's 3K, that string has 3,000 individual filaments in it. So a filament is thinner than the human hair, obviously significantly thinner than my hair. And if you have fewer filaments in a tow, then when you weave it into a fabric, those fibres stay straighter as they weave in and out of other.
Got you.
And the reason that matters is a bent fibre is less stiff and in the long run, less strong than a straight fibre.
Yeah.
So if you build a bit of a mental model,
yeah,
unidirectional, straight, stiffer, stronger. 1K, so small toes, small yarns, woven, a little bit less wavy, but more wavy than straight.
Yeah.
A little bit less strong, a little bit less stiff. 12K, big, quite chunky toes, quite a lot of bending to get over each other, and therefore quite a lot of stretching happens just to flatten them out.
Yeah.
So that it does make a difference to strength. I can't put an exact number on it. The designers will use woven and will use higher K counts, so 12K, probably not 24 in a bike, because it has other properties. It's tougher. The cracks don't travel as easily through it. It's easy to form around tricky shapes. There's good reasons to use it, but if you use it everywhere, the bike could be heavy and dead feeling, like early composite bikes. Like when I started riding, they had this reputation for being a bit dead, quite stiff. There was a lot of woven in those bikes.
So it can really change the properties then of a frame if it's used in different places?
Oh yeah, 100%. Modern bikes are brilliant in comparison to bikes when I was a kid. A lot of that is because people have understood how to use layup. So how to control the build-up of layers. So carbon fibre composites are made up of lots of layers of fibres putting in different directions. So composites are strong and stiff in the direction of the fibres. Bikes have loads, so forces, acting in a few different directions. So you need fibres in a few different directions to resist those forces. If you use woven, it's quite stiff and strong in the two directions and medium strength in the off axis, so in those other directions. So it's quite hard to tune a down tube so that it's really stiff in bending, so it takes your weight, because it's sort of quite stiff in lots of different directions. Now you can use a lot of the colourful engineering drawings you see from people. That's the calculations you do to design where the fibres go, so the bike is stiff in the right ways at the right places, and that makes a huge difference. So the majority of the weight loss in composite frames over the years has been better layup design, and it's safe because the quality of manufacturing has improved as well.
Okay.
The materials are kind of the same.
So you'd say it's that layup process?
Yeah, so in cookery, if you gave me and Delia the same ingredients, whose dinner are you eating?
Well, you've never cooked for me, but I'd probably go for Delia.
It really matters. The way you use the materials can make a huge difference. A material which is all orientated in a strip is quite hard to bend by hand. For the exact same size of plank, the exact same material, those fibres running across the plank, you can bend it with a finger. Fibres running crisscross at 45 degrees, you can bend it in somewhere in between, but you absolutely can't twist it. It makes a huge difference. So a unidirectional layer is well over 10 times stiffer and stronger in the fibre direction as compared to a cross. Like, it's a big difference. And I think, preempting one of the questions I think I saw, even a couple of degrees change.
Yeah, so like if it's misaligned, like what difference does that make?
The stiffness drops off really quite quickly. So 10 degrees off where you're planning, and it can be more than 10%, can be up to 20, for quite small changes, like changes you would struggle to see if you weren't looking properly.
Yeah.
So it's a big deal.
Amazing. And we're seeing more brands like talk about different curing methods and like molding tech. What's the latest technology in that kind of manufacturing process, I guess? And in your book, like, is it making a big difference compared to years ago? The best made frames from 15 years ago were already really good. A lot of the changes is being able to deliver well cured and well consolidated, so all the layers compacted together without wrinkles, quicker. Okay.
So when I visited factories years ago, the quick frames had wrinkles and some other like cure related problems, and the frames from really high quality facilities were cured slower in processes that looked more like traditional aerospace or F1 processes. Slow, expensive, and you really struggled to put units through. So a lot of the innovation that's happened, as far as I can see, has been in making faster processes that cure the resin, so apply heat in just the right way and pressure in just the right way, so that the chemistry happens. Again, cookery analogy, you need to cook the cake at the right temperature. If you cook it to higher temperature, it kind of burns on the outside, still gushy in the middle. It's really similar for composites. But applying heat in the right way can mean you can speed that curing up. Applying pressure in the right way means you don't wrinkle. So in another video, you've had a go at using composite to repair something, and you learnt firsthand it's kind of tough to keep thin, flexible fibres where you want them. Now imagine you're using pressurized air to force them into a mold. It would be super easy to get them out of orientation. So there's loads of innovation around carefully and controllably pressing things into the right shape. So it improves the quality of the product that can be made quickly, which means that we can afford to buy it.
Okay, got you.
Yeah. People have never sold bikes that are too expensive for people to buy. They've just tolerated different qualities of composite because it's hard making good composite quick.
Got you.
people like me and thousands more are working really hard to do that. And like some of these innovations are going into the bike industry. So we just get better quality frames, which is great. Yeah, I think it's all that.
Yeah, so it's possible to get those better quality frames in a larger number, and the general public gets to ride them, essentially.
Yeah, for sure. Like right back in the day, the very high-end frames were brilliant. Like Calfee's particular one, like big up to Craig, was great. Aerospace process, really expensive.
Yeah.
And some of the brand names I won't mention were not, but we could afford to buy them.
Got you. Yeah.
And now it's rare that I've seen a terrible composite frame come through.
Got you.
I think that's a big improvement, right?
Yeah, for sure. That's exciting for us to be able to ride those bikes which were totally unattainable before.
Yeah.
And just delving into like the materials as well, being used. What would you say is more important, like a really quality carbon fibre or a really good resin? Or am I making that too basic? Is there like any like?
Those are both important. The most important thing is a really good engineer.
Okay.
It comes back to that Delia thing.
Yeah.
You know, you can make a great bike. In fact, most bikes are made of medium modulus, like high strength medium modulus fibre, and you can make a massive difference. Right? Shed a huge amount of weight, have it ride the way you want it to ride by engineering it really carefully. You can get to great with normal material. You can get to great using jazzy material and less engineering, but you can get to great with normal materials. You can then get to wow if you add the good stuff in on top. But I think it is, obviously as an engineer, massive bias. But the laws of physics are on my side.
Yeah.
How you use it is more important than what it is.
That's really interesting.
But it's significantly harder to market.
Yeah. Got you. And in terms of like carbon fibre failing, like crashes, stress, like use over time, is there like a tried and trusted way to like know yourself that you've pushed it past its limit?
If you hadn't used the word yourself, yeah, definitely. Like you can absolutely use non-destructive testing, ultrasound, but that's a job for a professional. A carbon fibre repair shop will have an ultrasound scanner, just a handheld one. So you can tell for sure. In your garage, if you can see it, you should probably get it checked. You can do what's called a tap test with like a coin and tap down the tube. Somewhere where you know is good, hasn't had a knock, it'll sound like glassy, it'll almost ring like have that ceramic-y quality to the sound. And when you get to somewhere where it's damaged or either the layers are separated or that it's cracked, the sound will change. So it goes more dull. It doesn't ring. It's normally lower in pitch and it's quieter. Because where there's like separated material, sound can't resonate. It's like a cracked bell.
Yeah.
It can't resonate and ring the same way. That's pretty good to tell you if something is terribly wrong.
Yeah.
But realistically, it's really difficult, actually. You should err on the side of caution. If you've done a coin test and it sounds dead, please don't ride the bike. Please don't ride the bike. Take it to a shop. Take it to a specialist for repair. I won't give a spoiler for the other video, but yeah.
But as Peter's talking about, I tried to repair my own budget carbon frame, and you can watch the video now. It's on the Tech channel to see how I got on. But yeah, try not to give any spoilers. But I had quite a tough time with it.
Yeah.
Sorry, I was just saying, like if you do crash a bike carbon frame, should you get that checked professionally, or if you get up, there's no visible damage on it? Is that like? Would you?
Oh man, that's really hard.
Because I know it's a tough one. Because like crashes, I've been in many. They're always so different to one another. There's so many different things happen. You go one way, bike goes another. Sometimes you don't even see what happens to the bike.
Yeah, exactly right. I'm going to rely on the GCN crew to put all the appropriate caveats on the video. This is not legally binding advice. If it's hit something, check.
Yeah.
If it slid across the road on the bars and the saddle, you're probably okay. But if it has been stopped by something, as in like slidden into the Armco or you, get it checked. Like a paint chip could be a sign that there's more. It doesn't necessarily have to be a paint chip. Like you can have damage on the inside just from having flexed the wall in. So if it's taken a hit, check, like coin tap. If it's squidgy, that is the technical term, that's a sign that like that's not a bike for outdoors. That's going to be checked. Composites are not fragile materials. They take abuse, they can be hit, and you can continue to use them in some cases. But once they've actually been damaged, like if they've taken a hit that does damage, then over time that damage can grow. So on day one, it might be fine, but gradually it can creep out, and gradually it could become a problem. So it's definitely a stitch in time saves 9 situation. If it has had a hit, go get it checked.
Yeah.
If there's damage, go get it repaired. Because that bike is good for time. You know, once a repair is made by a professional, it's normally stronger and stiffer than it was before. It can last for years. Please don't chuck it out.
Good advice. I mean, also just on that as well, are there like, you've kind of covered that, but are there any warning signs of a damaged frame?
Yeah, so that's a good question. Modern composite bikes on the bigger main tubes, I'm looking at the bikes in the background, on the bigger tubes, the walls are really thin and you can generally feel a bit of flex.
Yeah.
If it's significantly more flexible in one area, it's probably because the layers have separated. Like we talked a little bit before, if you get like 5 sheets of paper and cardboard, which is about the same thickness, the 5 sheets of paper are really flexible, they just flap about. The same amount of material in one solid sheet of cardboard, pretty stiff.
Yeah.
You know, you want a cardboard frame. You don't want one that's made out of 5 sheets of paper.
Yeah.
So where it starts to separate is really squidgy. So the coin test, is it locally squidgy? The eyeballs just aren't that good a indication.
Got you. And like you kind of alluded to it as well, like saying that get your frame repaired. How long is a carbon frame's lifespan? Like how long is a bike lasted if you bought it?
A well-designed carbon fibre structure, as I can stress, well-designed, engineering is really important, it'll outlast you.
Really?
Yeah. If it's used within its limits, looked after, the fibres don't really have a fatigue limit. The resin does, but it's really unusual to see a well-designed, well-made bike that's been used having the composite fail. So the actual carbon fibre, it's much more likely that the places where you connect it to something else, so like the metallic inserts is a classic, places where you clamp to it, those things can fail. And that's where you see like the long age limit problems. Like be super careful around headsets, bottom brackets, dropouts, seat posts. Those bits where metal are joined into carbon, that's an interface between 2 different materials, that will probably fail long before the rest of the material does. But with care, with being looked after, you can have bikes for life. I ride a 2007 Cannondale System 6. Not worried about the carbon. I'm a little worried about the bit where it joins up to aluminium, but I keep an eye on it.
Yeah.
20, 30 years, no drama.
Amazing. And how does that like fatigue over time compare to other materials in bikes like alloys, steel?
Really similarly, because they're all designed for stiffness. You see all the bike engineers are right now shouting at the screen, but for a product to fail in fatigue, it means they haven't been designed well. Early aluminium bikes used to fail early because they didn't account for fatigue. Steel bikes are forever. Modern aluminium bikes will probably gradually get softer, just because of the chemistry of aluminium, or material science, not chemistry. Titanium, again, you're well outside its fatigue limit. It's not a material property that's the issue. It's when you use the amount of material needed to make a bike that's stiff enough and just strong enough. It's like a combination of size of tube, stiffness of material, strength of material, and sometimes, in aluminium's case, it knocks into the fatigue limit. I'm having a hard time not carrying on talking about that, but that's probably the most we can get out without the whiteboard and some diagrams.
Yeah.
It's not material, it's material and product and the way it's designed.
God, yeah. So it's a big package.
Yeah.
So it's not as simple as me asking you now, like, what material would you buy for your own bike?
From a performance and technical point of view, you can make a great bike out of any of them. They'll be slightly different. You should be able to make a bike that will last 10, 20 years. 10 years for aluminium, maybe not 20, out of any of them. I ride metal bikes for sustainability reasons. I ride second-hand carbon bikes because that investment of energy and environmental impact is made, and I'm just making good use of it. So I choose to ride metal bikes, and where I want a really high-performing bike, I get second-hand carbon.
Okay.
Sorry,
when you're talking about those lifespans, you mean 10 years riding that bike every day? That's like 10 years use. It's not like 10 years...
No, it's not like 10 years sound carriage once a month. With the best will in the world, even someone dropping the megawatts is going to struggle to break the material, like the carbon fibre material, through use. Like you might, because you're putting a lot of load into those dropouts, you're seeing a lot of load into handlebars, particularly like a big boy. Like those points, they might struggle. That's not really a composite material problem. That is the way those are designed to interface with metal bearings. Like it's a feature on the product. And you get problems like that around dropouts on metal bikes too, because it's a complicated shape with load of load going into it. That's kind of annoying to make. So it's a recipe for something to go wrong in the long term. So I think, and because people think, wow, lots of reasons.
Okay.
It's not a carbon thing.
Okay. Got you. No, that's really interesting. And in terms of the future, what's the future for carbon? We're seeing more sort of different aspects talked about, like graphene. Is it flax seeds as well?
Well, not the seeds, the flax fibres.
Flax fibres, yeah. That's spoken about in terms of going into carbon. That's something I don't really know about at all. We're going to see more of that.
I think you will see flax and natural fibres in general for sustainability mostly. Graphene, I think, is already in products. There have been frames that have used it as an additive into the resin, makes the resin a bit stronger. Does some other things, but makes it stronger. Graphene as a powder is here. It is nearly impossible to make big sheets of it or fibres of it in an industrial way. So when you hear things like however many times stronger and stiffer than steel, that's great at a nanoscale. It doesn't read up to something you could put in a factory to make a bike of. But they can make small incremental improvements. Right? It's small incremental improvements.
Oh, yeah.
Like Kevlar's been around for decades. Flax has been around for over a decade, and in bikes being used to create damping. So it can have a slight improvement in the damping that the material has. But any effect of those sorts of things, like damping materials or whatever, vastly outweighed by dropping your tyre pressure by a couple of PSI. Silka has a great website with actual hard numbers. Unless you can see something flexing because it's got a special shape, it's probably not as important as tyres Trek de Marne, the old Canyon flexi seat post, you can see why they're going to bend more. That's real.
Yeah, got you.
Tyres, you can see why it's absorbing impact. That is real. There is less robust engineering evidence around a difference a person can feel. I could detect it with a machine, but probably not with my butt.
Interesting. Okay. And what about other things like thermoplastic carbon? That's another one that's been spoken of.
Yeah, and that's again, it's been around for decades, used in bikes. I really hope your video guys can find footage of a super cool GT mountain bike from back in the day. The LTS or STS had thermoplastic tubes and aluminium joints. Almost all the carbon fibre composites used in cycling are thermoset. So you have a resin, you apply heat and pressure, and it cures. So the molecules join together to make it hard. So that's like pastry. Mix it, cook it, hard. You can't melt pastry. Thermoplastics is chocolate.
Okay.
Right? When it's hot, it's a liquid, like super smooth and runny. And then as you cool it down, little crystals form, and those crystals join together, and gradually it locks up into a solid. Exactly what happens in chocolate is what happens in thermoplastic. So from a bike point of view, you can melt the thermoplastic and change the shape, cool it down, stays in that shape. Pretty cool for manufacturing. You have to get it quite hot to do that. It's tricky business. You end up putting a lot of energy in. There are some theoretical benefits for recycling because you can melt it and repack it. You can do that with thermoset as well. It is useful, tends to be a bit tougher, so it's not brittle as a plastic. You can do some interesting things with forming and moulding. There's been some good stuff done on wheels for thermoplastics. But it's quite hard to stick to. Like epoxy is a glue. It's really good at grabbing onto other stuff. Thermoplastic is a problem. Like it's difficult to bond to it because it has properties that mean most glues don't stick. So you have to really think hard. And obviously quite a lot of the assembly that goes into a bike frame relies on some degree of bonding.
Yeah.
So it absolutely can be important, but it would really, if I was looking at a thermoplastic bike, I would be looking really, really hard at any place it touched something else. And we'd want to have a whole conversation about why those bits aren't just going to fall off the first time I sneeze at it. But it's super important, right? Like we said earlier, the bike will last for a long time, but it's the contact points, the places where it gets bolted to, that are likely to go.
Yeah.
And thermoplastic makes that harder. I'm sure lots of people will get in the comments and tell me I'm wrong, but I'm not.
Okay. And in terms of let's talk about sustainability.
Yeah.
It's a big talking point at the moment in terms of carbon bikes, carbon frames, carbon components. Going forward, I guess what's your opinion on the sustainability of carbon bikes?
So it's kind of, the first thing to say is a carbon bike and carbon products in cycling are optional. They are luxuries. And that's kind of important context for what I'm about to say. Making carbon fibre in particular, but also resins, is environmentally damaging. Right? Both of the materials that go into the feedstocks are coming out of crude oil. There are some biomaterials coming through. We'll kind of I'll touch on those in a bit, but the majority of composite materials come from oil. It is better to have oil turned into materials than it is to have it burnt and heating our planet, but it's still not good. You are using energy, committing resources, creating pollution to make these materials. Right? And there's not an easy way to reduce that. We'll get onto the bright and shiny future in a minute. So when you choose a luxury item that's made of a material which is really quite environmentally damaging to manufacture, and you change it every couple of years, that's not okay. You are putting a lot of energy, a lot of CO2 into the environment, and then taking something which could be a brilliant bike for years and years and years and potentially putting it in landfill. Now, for me, it's personal choice, right? I don't think that's the right way to live a life. I think as an industry, we pride ourselves on being more sustainable. You ride to work, you're not driving your car. And that's great. Right? I think that's really, really important. And it's really tricky to justify changing a composite bike, chucking something away that could be there for a generation to get a better paint job.
Yeah, I guess the flip side to that, and like the counter argument is, if you are someone who does change their bike regularly, most people would sell that bike on. Yeah. It's still in the it's out there in the world and being absolutely used. I think for me, like hearing that, a big takeaway is if you've damaged a frame, not to chuck it.
Yeah,
that can be professionally repaired. That could be sold on if you wanted to and still used, rather than giving up on it.
And I think that's it. So I said at the start, I ride second-hand composite bikes because they're generally still good for it. And I've had one over 10 years now. And I think that's a really good point. You know, there's a finite number of people in the world that are going to buy a second-hand bike, and but it's a good point. You can sell it on, and you should. You should repair it. You definitely should repair it. But there are some really good metal bikes out there. I think the way forward, there's been some great stuff written in some bits of the cycling media about more sustainable ways for the industry to run. Some bits of thinking about recycling composites are happening. You can get the bikes ground up and used as input for molded composite stuff. So the shorter fibres going into a polymer that gets molded into a small complicated component like injection molding. And that's good. It doesn't keep a lot of the value and the benefit of having long continuous fibres, but it's better than nothing. Really, what we want to get to is a good use of material that has a long life, and this is something which is really kind of going to progress quite quickly, a clear route to reuse that material in a way that still has lots of value. So I'm really lucky. I get to see a lot of stuff early doors. There are technologies now where you can reclaim continuous carbon fibre from fairly simple products like a tube or a pressure vessel, like a pressure tank, because you can unwind them. It's cool.
Yeah.
And it's very nearly as strong as when it went in at the start of its life. Carbon fibres are good, right? You can reclaim all the value of the resin. You can reuse the carbon fibre. That's real progress. But if you then think of a bike, that bike is made up of a patchwork quilt of fibres, sometimes different fibres.
Yeah.
So even if you get all the glue out, it's going to be really difficult. Well, you know, you've handled carbon fibre, right? Imagine trying to take it all apart when it's all tangled and fluffy, and turn it back into something which is beautifully aligned and ready to go again. Like when you actually think it through, that's going to be a very tough ask, and something which would be exceptionally hard to do at an industrial scale. You can, and there are people already doing it, turn it into other shorter fibre or not aligned fibre product. That's really good, right? That is the right thing to do for now, until somebody comes up with some proper Star Trek technology to take the patchwork quilt and turn it back into pristine fabric.
Yeah.
You know, doing what I do for a living, that's going to take a while.
Wow. Okay.
So it is. That's why I started off by buy something you love, treat it like you love it, and stay faithful. Like that is honestly the best, most sustainable thing to do.
Interesting. Yeah, something I'm definitely going to take away from speaking to you. And one question as well, I kind of forgot to ask, but it kind of leads on from that, in terms of buying second-hand carbon bikes. And we touched on it earlier in terms of fatigue and lifespan of a bike, but can the properties of a frame change over time, of a carbon frame? Can it become less stiff or
less stiff? No, not without real problems. So the carbon fibers do not degrade properties. To the scientists, there's a very small caveat, but talk amongst yourselves. The actual frame, if the resin may degrade slightly, but you will not detect, again, like you won't feel it in these or that before it becomes a much bigger problem. You might see flex at the dropouts. It's not the carbon fiber softening, it's an interface softening.
Yeah.
We think we are more sensitive than we truly are.
Interesting. Because I always had this thing when I was racing that you'd get to the end of the season and your like race bike.
No, mate, you were just tired.
That's what I think I probably just was. Yeah, wouldn't feel the same as you did at the start, but it was all in my head.
Well, wheels, handlebars,
yeah, exactly.
Bearings.
Yeah,
like it's October. Everyone's sad in October because you're about to grind out of 4 months of hard training. It definitely wouldn't be measurable, for sure not. And if it was, again, like you're a big lad, you were super powerful. Maybe there was something happening at the dropouts. Maybe. I'd be really surprised if you could hear that. I mean, it'd be fun. I would love to get some proper science behind all of this stuff.
Yeah.
But again, depths of the internet, time and time again, you can measure more than you can feel. There's a ton happening between your ears that the laws of engineering doesn't have a ton to say about.
So if you are going for a second-hand carbon bike, you can go for it with confidence because you are getting pretty much the same properties as you would have got when you bought it brand new.
Stiffness, I think that's probably a good summary. Don't fret about it being less high performance. Do be confident that it's still as strong.
Yeah.
Any hint of it being crashed, walk away. Like there are lots of really reputable places that scan and check frames before they sell them on. That's worth doing. The stiffness thing, it'll perform the same.
Big thanks to Peter for coming in and sharing his expertise with us. It's been really fascinating actually for myself to learn more about carbon fibre. It's almost something I've always taken for granted that it's been in pretty much all the bikes that I've ridden, and to learn about it from someone with the knowledge that Peter has been really eye-opening, and as I said, absolutely fascinating. Do let us know in the comment section down below what you think of carbon fibre as a material to ride on. Is it your go-to, or are you someone who prefers a metal bike, and why? I hope you found this video useful. If you did, please give it a big thumbs up, and as always, thanks for watching. We'll see you on the next one.